this thanks to one fish, the lionfish.
The lionfish, sometimes called the zebrafish, is of the Pteris genus and scientifically known as the Pteris volitans, red lionfish, and Pteris miles, devil firefish. Lionfish have vibrant stripes of brown or maroon, contrasting with white across their heads and bodies. They are known for their venomous spikes and menacing fan-like pectoral fins, elongated dorsal spines, and rays. Fully grown, lionfish can be up to 18 inches long. It's easy to see why lionfish are such popular aquarium fish.
Lionfish are native to Southeast Asia, from Japan down to Australia, and come as far west as Africa. They are found in mostly all marine habitats, but mainly in the warm marine waters of the tropics. Lionfish have been found in water depths from 1 to 300 feet on hard bottom, mangrove, seagrass, coral, and artificial reefs, such as shipwrecks. Lionfish are not native to Atlantic waters, and actually originate from the other side of the world. The lionfish is the first marine invasion in the Atlantic. So how did they get here? Theories include pet owners who began to set their fish free around 1985, or an aquarium accident during a hurricane in 1992. In any case, DNA evidence can trace the population back to 6 or 8 lionfish that began the entire Atlantic population. Almost all theories point back to humans as the reason for this rapid invasion.
Here we are with a local off-duty fisherman, Jimmy Menace. Thank you for being here, Jimmy.
Thank you.
So, can you tell us a little bit more about some of the problems associated with lionfish moving into the Atlantic?
Well, lionfish have become a problem because they're carnivorous, breed rapidly, and they have no natural predators in the Atlantic. And they would be a lot less of a problem if they didn't attack and eat all the native fish like grouper and snapper, who are really suffering the invasion. In fact, they eat so many of these fish that they are putting the survival of both of the species in the Atlantic at risk.
So, how did the lionfish establish such a strong population here?
Well, they reproduce very rapidly. One female can lay up to 2 million eggs per year, which is almost 5,500 each day. And this poses a threat as the lionfish population will exponentially grow, ensuring that one day they will outnumber their prey, leading to the prey's extinction.
Why are lionfish thriving? Shouldn't there be some kind of natural balance keeping them in check?
Actually, lionfish have no natural predators in the Atlantic because they're invasive. This means that their growth has nothing to check it. It also means that there's nothing to stop the lionfish population from growing so large that it shuts down the entire ecosystem of the Atlantic. Luckily, cold water temperatures are keeping their numbers in check to the north, but there's nothing happening to stop them in the south, where lionfish are spreading rapidly through South Florida estuaries, the Gulf of Mexico, and the Caribbean Sea.
Can you elaborate on some ecological issues associated with this?
Well, lionfish occupy the same trophic position as snapper and grouper, thus creating competition for smaller prey and hindering repopulation efforts of the other fish. Also, they impact many other trophic levels by eating species like parrotfish that would otherwise consume algae and keep coral healthy. Reports show that once lionfish populate a new area, native fish decline by roughly 80%.
Wow, it sounds like we have a real problem on our hands. Thank you so much, Fisherman Jimmy.
You're welcome.
To understand how lionfish are impacting reef ecosystems, it helps to know a few ecological basics. Nutrient cycling is the uptake, use, release, and storage of nutrients by plants and their environments. A food chain is the sequence of who eats whom in an ecosystem to cycle nutrients. The arrows in a food chain show the flow of energy from the sun or hydrothermal vents to a top predator. As the energy flows from organism to organism, energy is lost at each step. A network of many food chains is called a food web.
The trophic level of an organism is the position it holds in a food chain. Primary producers are at the bottom of every food chain. These are autotrophs. Primary consumers are animals that eat primary producers. They are also called herbivores. Secondary consumers eat primary consumers. These are carnivores and omnivores. Tertiary consumers eat secondary consumers. Quaternary consumers eat tertiary consumers. Top predators, also called apex predators, are at the end of food chains. These animals have little or no natural enemies. When an organism dies, it is eventually eaten by detrivores, like worms and crabs. and broken down by decomposers, bacteria and fungi, and the flow of energy recycles and starts anew.
Growth curves are frequently used in ecological studies. They show the rise and fall of populations of plants, animals, and other multicellular organisms over time. A population cycle in zoology is a phenomenon where populations rise and fall over time.
Here we are at Goshen College to meet with 3 college graduate students, Sam Wendell, Cecilia Atkins, and Jimmy McNiff. They're studying marine biology, and more specifically the lionfish invasion in the Atlantic. Recently, they wrote their theses about the lionfish invasion and have agreed to talk with us more about the facts, their opinions, and the differing views regarding the possible solutions.
So there have been several proposed solutions for the lionfish catastrophe. The most common and well-supported has been the hunting and systemic removal of the fish from the Atlantic. There are 2 main opposition groups to this solution. The first group believes that the unregulated and unlicensed killing of the fish will make it easier for poachers to get away with killing other fish, under the guise that they intended or tried to kill a lionfish. The other main camp primarily consists of members of the government. They believe that fish cannot be killed or removed from government-owned reefs, and this includes lionfish.
A solution that has yet to succeed on a large scale is eating lionfish. Proponents of this solution aim to turn lionfish into a commercial food source. However, the process of despining and preparing lionfish is labor-intensive, and lionfish dishes end up being fairly expensive and of little demand, which doesn't bode well for hopes of a sustainable market for lionfish.
An outlier solution is to teach other fish in the region to hunt lionfish. There are 2 main methods to do this. The first is to feed local fish like grouper and barracuda dead lionfish. The second is to chain live lionfish to tethers and wait for them to be killed and eaten. The big issue with this solution is that the local fish will not learn to hunt the lionfish on their own. Instead, they'll rely on humans to feed them. Moreover, as scientists have seen in the past, when fish are taught to rely on humans for food, they may attack humans, seeing them as food, or expecting food from them.
In recent years, lionfish derbies have sprung up in Florida and other affected areas. During these single-day events, large groups of divers gather to attempt to catch and remove as many lionfish as possible.
Unfortunately, derbies alone are not enough to deplete the overpopulation of this invasive species. Legislation will be a driving force in the slowing the spread of lionfish. Last year, Florida outlawed the importation of lionfish for aquariums. The Florida Fish and Wildlife Conservation Commission also banned the intentional breeding of lionfish and the possession of lionfish eggs. Furthermore, it is now legal in Florida to hunt lionfish without a recreational fishing license, expanding opportunities for the capture of these fish.
Moving forward, scientists and marine lovers must agree on what the best solution to the lionfish problem is. The best solution appears to be the systematic hunting and controlled removal of these fish from the Atlantic. This would allow for the lionfish to be removed on the largest scale possible, hopefully putting a real dent in the Atlantic population. We must also look at how the lionfish arrived in the Atlantic and continue to take measures and enact new legislation to stop another invasive species from causing the same problems. The integrity of fragile Atlantic reef ecosystems are at great risk if this catastrophe continues at its current rate. Lionfish are present in the Atlantic due to human interference. It is now our duty to reduce the impact of this invasive species and restore the health of the many affected marine ecosystems. The time to act is now.